Today we're going to talk about clean code, maintainable code, software design, and in general how not to lose our minds when we're writing software products. In the past few years, I've been predominantly focused on learning software design, software architecture, and high-level patterns. The question that I keep getting is it worth it to continue studying clean code? Is it worth it to continue studying software design in general? Is this a skill that has good long-term shelf life in this world? Because if AI is writing our code, does it matter how good it is? Is code now an abstraction? Are we only thinking about boxes? Are we only thinking about modules and high-level ideas, and code is just something under the hood that whose structure we don't think about? The short answer is yes. Software design is still very important. But to answer why, we gotta step back. Now, first, there's an important distinction that we have to make. When most people say clean code, this term has become the norm for writing maintainable, well-written, well-structured code in general. But it comes from the book Clean Code. And the ideas in clean code and what people mean when they say clean code in general sometimes deviate. Clean code is a very opinionated book, and it has some rules which many people don't agree with. And you can have like a couple of engineers arguing if a piece of code is clean, but they don't mean like whether it follows the standards from the book. They mean whether it's well structured or understandable in general. Clean Code is a good book. It has some very good ideas in it, and I think it's worth going through it. Now, some of them are taken a little bit to the extreme. One of the ideas that the book is notorious with is that functions should be 5 lines long at most. In general, it's good for functions to be short, it's good for them to be focused, and it's good for them to do one thing and one thing only. But using function length as an arbitrary metric about how good a function is not really a good practice. Yeah, it's good to avoid long functions because this usually means that they're doing too many things. But you can have like a lengthier function that is still focused, it completely encompasses one logical operation, and I think this is better than trying to arbitrarily split it into smaller ones. Clean code also says a lot about things like comments. According to the book, code should be self-documenting. So if you're writing comments, this means that your code is not written well enough. The vocabulary of a programming language is limited compared to the vocabulary of like English. You may lack the ability to explain what exactly you're trying to achieve with a programming language. Code is usually good, like reading the code is good at explaining what it's doing. So you can read the code and understand what it's doing, but understanding why it's doing it, this often requires business context that is not present in the what. This requires the why. And the why is usually given, it's best given as some sort of a comment, like explaining the business reason, explaining the domain specific that requires this code to be written the way that it is. When I say that I've been learning software design, I don't mean that I've been trying to implement these ideas in the code bases that I'm working on. Software design is how you structure a code base, how do you organize it, what design patterns do you use, when do you not use design patterns, like how do you create your abstractions, how do you design the API for a function or a class or a module. Just in general, how do you make sure that this code base remains maintainable? I've been exploring the different ways to build software and finding out the correct principles and ideas that help us write code that we don't have to rewrite each year. So there are essentially like 2 types of programming that we usually do. We do like tactical programming and strategic programming. And tactical programming is about like the low-level details. How do you make sure that this function spews out the correct data? How do you get this value from here to here? How do how do you map through this collection? How do you do this? How do you solve like specific problems in the code base? Strategic coding is more about like organization, structure. What pattern do we apply here? Do we apply a pattern? How do we split this logic into smaller units that we can understand? Should we do this? Tactical coding is how you solve the problem that you have right now. This is about solving short-term problems. Strategic coding is how do you make sure that this application remains maintainable. LLMs are incredible at writing tactical code. At the time of this video, you can put cursor in agentic mode, ask it to make like a large change in a code base, and it will do it. But it may not do it in a strategic way. It is focused on solving the problem that you present to it. But whether it solves it in a way that puts this code base in a good, maintainable, and extensible position that you can continue to work on is questionable. I had this experience where I was working on a vibe-coded code base. Like friends of mine, small startup, they had created like a prototype for UI entirely with Cursor, and they had some obscure bugs that they couldn't solve. And Cursor could no longer solve them, and any change that they made broke something else. And the problem for that was that the whole thing was tactically coded. It was created so it can solve specific problems. It wasn't generalized. It was a specific solution. And when you tried to accommodate new logic in it, when you tried to change how it works, the whole thing broke. Like you couldn't change one thing without breaking another. And this requires you to do like more tactical coding and more like cheating and hot fixes. And it helped me realize that like the tools that we have right now are very good at solving like low level specific problems, but they are not good at software design in general. Understanding, like learning the principles of clean code, how long should a function be, where you should write comments, this on its own is not that valuable as knowledge. Learning about software design, however, is like learning how to manage complexity. Like you have some complex idea, some complex functionality that you have to present in the code base. Understanding how you want to package this in terms of functions, whether it should be a class, what should the API of this class be, how should this be, how should this be presented to the outside world, to the other developers that are going to work with it. This is the challenge that remains in your hands as a developer. Like writing the tactical codes, this is, I think, a solved problem now. Like you can tell Cursor, write this algorithm, implement this function in this way, and it's going to do it. But you need to have like the design thinking and overall, high level picture view of what you want this software to do. You need to have like the domain understanding and knowing where you want certain functions and certain classes to be extensible, where you can go with a specific implementation, where you want to make something more general. So what you absolutely need to study is software design. And the problem with this is that we have not focused on this enough as an industry. Like usually in academia and in boot camps and in tutorials, people have been focused on achieving a specific goal. Like people have been more focused on technical programming. Like how do you achieve this? How do you write this algorithm? How do you, get this framework or this library or this tool that you're using to do what you want out of it to do? How do you get the language to behave the way that you want it to behave? But we have not focused on, hey, how do we create maintainable products? Like we want to write code bases, we want to build solutions that can exist for like 10 years, but how do we actually do this? And we are now entering, a time where the skill that is most valuable, I think, is the one that we have spent the less time on. Like we have managed to automate writing code, and we're now left with a harder problem for us that very few people have spent time even thinking about. Like, because in order to do good software design, it's not enough to know design patterns. They are a ready-made solution, but what's important about them is like the principle behind them. If you understand the principles behind them and you can apply these principles and these ideas in other situations, that's valuable. It's valuable to know when not to, to use these patterns. And we have just not spent the time on this as an industry. And like the excuse that we had so far was we don't have time. We don't have time to write good code. We don't have time to write well-structured code. We're pressured. The business wants us to ship faster, so we got to do it. But like right now, whether you write bad code or whether you write good code doesn't depend on the time that you have. It depends on your understanding and your taste in code and your knowledge about what good code actually is. Because whether you generate bad code or whether you generate good code depends entirely on you and your understanding of software design. So yeah, in short, learning about software design is absolutely worth it. And I think that is something that you should do. A very good book that will get you started is John Osterhout's A Philosophy of Software Design. It's a book that's had an enormous impact on my career and the way that I look at software. And it shows that it's written by someone who has a really grounded and practical understanding of of how software is built. I published a book of my own on this topic. It's called Full Stack Tao. It's about applying some of the fundamental software design principles in the context of JavaScript, React, and Node.js. So if you are into this, I think this is something that you may like. Shameless plug. So yeah, this is going to be it for today. Like and subscribe if you haven't, and see you in the next one.